Yesterday, for 2 minutes and 18 seconds, the sky went dark in the middle of the day. Birds stopped singing. The temperature dropped. And for the first time in over a century, mainland Europe watched the sun's outer atmosphere burn silver against a black sky. This was the total solar eclipse of August 12, 2026. And what actually happens during those 2 minutes is stranger and more violent than most people realize. Let's start with what you actually see, second by second, if you were standing in the path. About an hour before totality, the moon begins creeping across the sun's disk. Daylight barely changes. Your eyes adjust so gradually you might not even notice until the last few minutes. Then, in the final seconds before totality, the light turns strange. Shadows sharpen unnaturally. The temperature can drop several degrees in minutes. Animals, birds especially, often go quiet. Some scientists think they're reacting to the sudden chill and the horizon glowing like sunset in every direction at once. And then, right before the sun disappears completely, tiny beads of light break through the valleys on the moon's jagged edge. Astronomers call this Baily's beads. It lasts only a second or two. Then, totality. The moon fully covers the sun's blinding surface, and for the only time you can safely look at it with your bare eyes, you see the corona, the sun's outer atmosphere, normally invisible, stretching out in silvery streamers millions of kilometers into space. This eclipse's totality lasted a maximum of 2 minutes and 18 seconds, at a point over the Greenland ice cap. Most viewers along the path, mainly in Iceland and northern Spain, saw somewhere between 1 and 2 minutes of it. That's genuinely all the time you get. 2 minutes after waiting years for the sky to align. So why does totality only last a couple of minutes? And why can't we predict a nice, evenly spaced schedule for these things? It comes down to a coincidence baked into our solar system. The sun is about 400 times wider than the moon, but it's also roughly 400 times farther away. That ratio means, from Earth, they appear almost exactly the same size in the sky. Almost. Not exactly. And that tiny mismatch is what makes eclipses so unpredictable and so precious. The moon's orbit isn't a perfect circle. It's slightly elliptical. Sometimes it's a little closer to Earth, making it look bigger. Sometimes it's farther, making it look smaller than the sun. This eclipse happened just 2 days after the moon reached its closest point to Earth, which is exactly why it was able to fully color the sun and produce a total eclipse instead of a thinner, ring-shaped annular one. Now here's the part most people get wrong. You'll often hear that total eclipses happen every year and a half somewhere on Earth. And that's roughly true globally. But this particular eclipse was the first total solar eclipse anywhere on Earth in 28 months, since the one that crossed North America in April 2024. That's a much longer gap than the average. Why the wait? Because the moon's orbit is tilted about 5 degrees relative to Earth's path around the sun. Most months, the moon passes slightly above or below the sun during a new moon, so no eclipse happens at all. Only when a new moon lines up almost perfectly with one of 2 points where the orbits cross, called nodes, does an eclipse become possible. And even then, whether it's total, partial, or annular, depends entirely on that sun-moon size coincidence we just talked about. This eclipse mattered for another reason too. It was the first total solar eclipse visible from mainland Europe since 1999, a gap of 27 years. Its path of totality was narrow, only about 290 kilometers wide, sweeping from remote Siberia across the Greenland ice sheet, clipping the west coast of Iceland, then crossing the entire Iberian Peninsula through northern Spain before ending at sunset over the Mediterranean. Millions of people traveled specifically to stand inside that narrow band, because outside it, Even by just a few kilometers, you'd only see a partial eclipse. The sun dimmed, but never actually vanished. So what does 2 minutes of darkness actually mean, scientifically? For astronomers, it's not just a spectacle. It's one of the only windows to directly study the sun's corona from the ground, without a specialized instrument blocking the disk artificially.